Hello everyone, welcome back to yet another session of the basic concepts of chemistry. Today we will look at the various physical quantities. These are the quantities which are expressed and measured in terms of numbers and units. The thing of interest to us is the units. So first we'll look at the unit system. The International System of Units has given us the 7 base units, and the fundamental base units, which are 7 in number, are meters for length, kilogram for mass, second for time, ampere for electric current, Kelvin for temperature, mole for the amount of substance, and candela for luminous intensity. In the subject of chemistry, we will mostly be focusing on the unit of mole for the amount of substance. But there are other units also, such as meters, kilogram, seconds, Kelvin, which are considered in this subject. There are various prefixes also which are used in the SI system. These prefixes are used so that the values or the numerical values can be expressed if they are many. Since atoms and molecules, they are numerous, we need to use these terminologies particularly, or these prefixes. The first one being pico for 10 raised to minus 12, nano for 10 raised to minus 9, micro for 10 raised to minus 6, milli for 10 raised to minus 3, centi for 10 raised to minus 2, deci for 10 raised to minus 1. For 10 raised to 1, we use the terminology deca. For 10 raised to 2, we use hecto. For 10 raised to 3, we use kilo. For 10 raised to 6, we use mega. For 10 raised to 9, we use giga. And for 10 raised to 12, we use tera. What is this mass and weight? Is it the same? Is there a slight difference? Or is there a vast difference between mass and weight? Yes, of course, there is a difference between mass and weight. And the difference is mass is the amount of matter present in a substance. So if this is that substance, this is the matter, and this will be called as the mass. Whereas weight is the force exerted by the gravity on an object. So if there is an object which consists of matter, if it is kept on earth, it will have one particular value for that weight, and if it is taken to moon, then it will show some other value for weight. So since it is a force, the unit for that will be Newton, and for mass the unit is kilograms. We need to keep in mind that mass is always constant. It does not change with location, whereas weight is not constant and it does change with location. Therefore, the weight of an object on earth will be different, and on the moon it will have some other value. Now we'll consider an example in which an astronaut is present on earth and is also taken to the moon. Firstly, to understand the concept of mass and weight through an example, we need to consider the gravity on moon and on earth. First of all, gravity on moon is always less than the earth, and gravity on earth is more than that on the moon. How did we know this? This has been taken many years of research by many scientists, and they have used many mathematical formulas to come up to this conclusion. They have also given us the exact value of gravity on earth, which is 9.8 meters per second square, and gravity on moon, which is 1.622 meters per second square. So from this we can conclude that gravity on moon is 1/6 of that on the earth, and gravity of the earth is 6 times more than that of moon. Coming back to the example of the astronaut, we have already said that mass is constant. So the mass of that astronaut, which is taken as 100 kg, is the same on earth and also on moon. But when we consider the weight, by using the formula weight is equal to mass into acceleration, we get two different values of weight. On the moon, the weight of that astronaut is 162.2 newtons, whereas on earth it is 980 newton. So this typical example shows us the difference between mass and weight. Weight keeps on changing depending on the location. Through this image, you can see that mass of the astronaut on Earth and Moon is the same, but weight differs. Now coming to the volume. Volume is the amount of space occupied by a substance. The unit for volume is meter cube. So if you take a cube which has all the sides equal, and let's name the side as L, by the formula for volume, it is length into breadth into height. So if all these are equal, then the answer for volume will be L cube. And we know that the unit for length is meters. So meters into meters into meters is meter cube. Besides this, there is also another unit which is used commonly for volume, and that is liter, but it is not an SI unit. But this unit is mainly used for the volume of liquids. These are the various apparatus which are used in laboratories for the measurement of volume. The common one being a volumetric flask and a graduated cylinder. The graduated cylinder has markings on it which gives us the volume of that particular substance. Besides that, we have some other apparatus which is a burette and a graduated pipette, which is also used for the measurement of volume. Now we have seen the relationship between mass and weight. Mass is not equal to weight. We have also seen what volume is, the definition of volume, and what are the various apparatus which are used for measurement of volume. Now let's discuss the relationship between mass and volume. The relationship between mass and volume is density. So density of a substance is its amount of mass per unit volume. Based on density, we can determine how closely the particles are. So we can find out the state of that matter based on density. The unit for density is kilogram per meter cube. The next physical quantity is temperature. Temperature is the measure of hotness or coldness expressed in terms of scales. We have three different scales: the degree Celsius scale, the degree Fahrenheit scale, and the Kelvin scale. The Kelvin unit is an SI unit, but we also use degrees Celsius and degree Fahrenheit as well. We need to keep in mind that the flow of heat energy is always from a hotter body to a cooler body, that is from a high temperature to a low temperature. Now we will see the various scales of temperature. We have taken three different thermometers with three different scales, and they are dipped in a jar of water. First, we'll consider the freezing point of water using a Fahrenheit scale. So it shows as 32 degrees Fahrenheit. For Celsius scale, the freezing point is showing as 0 degrees Celsius. And for Kelvin scale, it is showing as 273.15 Kelvin. Now let us consider the boiling point of water. For Fahrenheit scale, it is 212 degrees Fahrenheit. For Celsius scale, it is 100 degrees Celsius. And for Kelvin scale, it is 373.15 Kelvin. If we look at the difference between the boiling point and the freezing point for all the three scales, then we see that for Fahrenheit scale, it is 180 degrees Fahrenheit. For Kelvin and Celsius scale, it is the same, that is 100. Now, why do we need to know the difference between the boiling point and freezing point, and why do we need to learn the scales of temperature? This is because we have to solve certain mathematical problems using these scales. We should know how to convert a Celsius temperature into Kelvin or from Kelvin to degree Fahrenheit. For that, we have to build up a relationship in between Celsius, Kelvin and Fahrenheit scale. This is a basic summary of what we have already discussed through the figure. The freezing point, the boiling point, and the difference for Celsius scale, for Kelvin scale, and for Fahrenheit scale. Now we'll look at the formula or the interrelationship for the conversion between the various scales. The C defines the temperature. In this formula, the alphabet C defines the temperature. So if a question is given to you in terms of Celsius, then you will put C as the first part. The freezing point, as we all know, for Celsius scale is 0 degrees, and below it will be the difference. We have seen that the difference between the freezing and the boiling point is 100 degrees for Celsius scale. This will be equal to K. Now the question asked to us was in terms of Celsius, but we need to find in terms of Kelvin. For that, we have built up a relationship that Celsius degree temperature minus the freezing point upon the difference between the freezing and the boiling point is equal to Kelvin, the temperature which we need to find in terms of Kelvin scale, minus the freezing point of the Kelvin scale upon the difference. So by using this interrelationship, we can find the conversion of Celsius scale to Kelvin scale. Similarly, we can equate the Celsius scale to Fahrenheit scale or the Kelvin scale to Fahrenheit scale. The difference between the freezing point and the boiling point for Fahrenheit scale is 180 degrees Celsius Fahrenheit, and the freezing point for Fahrenheit scale is 32 degrees Fahrenheit. Using this interrelationship, we can solve many problems easily. So this is the last part of today's session. Further, we will see various type of chemical properties and how to go about with solving other kind of problems.